Welcome to Syntax. In this episode, we're going to be taking a part 2 to our series on promises. And in this video, we're going to be talking about error handling. We're going to be talking about aborting a promise, helper methods, and more. So, we're going to continue our talk on promises. And after this one, I think you'll have a great idea about a little bit more in terms of how to use them beyond just the basics. So, my name is Scott.
I promise you're going to have a good idea.
Yeah. Okay. Well, I promise you my name is Scott Talinsky, and I'm from Denver. With me, as always, is Wes Boss. What's up, Wes?
Hey, not too much. I promise that if you have issues with your promises, you're going to want to check out Sentry, because Sentry is going to tell you when your promises are thrown, maybe when you have an uncaught reject in one of your promises that you weren't expecting. I can tell you, Node used to have this thing called Node used to catch your uncaught promises, and they warned for years that they're going to turn it off. And I said, yeah. And then one day my server crashed. And whenever my server crashes, I get a little Sentry alert and I get an email about it. And I logged in. I thought, why did my server crash? And I looked at the Sentry error. It was a fetch request that I had not been, or no, it wasn't it was a fetch request, but it was a post. So I was posting some data to a third-party service. That service had an outage. And because it was unhandled, I didn't catch the error. My entire server crashed, which is unreal that it could crash an entire server just with a single fetch request. But that happens. And Sentry was able to tell me exactly what happened, and I fixed it in like 3 minutes. So check it out, Sentry.io.
Check it out. Sick. Well, let's get into the first section of this episode. We're going to be talking about canceling promises. So you have a promise, it goes off, and like I'm sending, or you're sending me to the store, right? The promise is that I'll return with the stuff. At any given point, you can call me up and say, hey, Scott, come back.
Yeah.
Cut it out. Stop doing what you're doing. I found the cheese in the fridge. We don't need any more cheese. Or
that's a good way. Yeah.
You can reject a promise at any time. So that is entirely up to you. And you can return with the resolve or reject methods at any time as well. You basically have control over the full process throughout which you're working with your promise.
Yeah, inside of a promise, you can, like we said in the last episode, you get your resolve, you get your reject methods, and you can do whatever you want with those. And often what that includes is you have some logic inside of your promise that says, given these use cases, maybe after I've tried clicking the button 6 times and it doesn't work, then reject. Or after, pretty common is you want to put a 5-second timeout on a promise. After 5 seconds, if this thing doesn't come back with data, or after 5 seconds, if the user hasn't clicked this button, then we need to do something in order to show them. So you'll catch the reject in that case. So that's an example of when you would want to put the logic inside of a promise. Also, we have Promise.with resolvers. Again, we'll talk about them a little bit more in the next episode. It's called deferred. But essentially, Promise.with resolvers will give you the promise, but it will also give you the resolve and the reject methods outside of the promise instead of inside of the promise callback. And that can be handy is if you want to pass those, like pretty much like succeed and cancel functions, if you want to pass them to something else. Like, for example, I have buttons on an example somewhere where if you press like the done button, that is resolve. But if you push the cancel button, that is a reject. Often you could just wire those up directly to an add event listener and you're up and running. So that's another way you can cancel them. And then also in fetch land, we have this idea called an abort controller. And you create an abort controller, and that abort controller itself has what's called a signal. You pass that signal to a fetch request, and then you're able to control that fetch request from wherever you have access to the abort controller method. It's a little bit more complex than simply just rejecting, because you do want to also cancel the network request, and that will take care of all of that stuff for you, as well as there's a built-in signal for simply just doing a timeout, because if you want to set the timeout of a fetch function, you don't have to wrap it or anything. You simply just pass the signal of abort signal.timeout, 500 milliseconds, and then that thing will reject if there's no response back after 5 seconds.
Why would you reach for an abort signal? Because that's not something I feel like I've ever had to do.
A good example would be if you have a type ahead that is sending off fetch requests. So you have a search box, you start typing in cool, and then you stop for a second, and it goes, I'm going to start searching for cool. So it sends a fetch request off to your API. And as that fetch request is in flight, you just type ify, fi. Okay, now you've sent off a second request to the server that for coolify. Now you have 2 fetch requests in flight, and it is not guaranteed that they will come back in order that you've done it. And often developers don't realize this because you're working with a local database and on local hosts, and there's no latency at all. But you get into real world conditions, your database is somewhere different than your actual user, there could be real world things. So as you are typing, if you are firing off a second fetch request, you need to make sure that you abort any other requests that are currently still in flight. So that's where you'd want to use an abort signal.
Thank you. Thank you for that.
Yeah.
Yeah. Well, let's talk about some of these additional helpers for promises. You may have seen some of these, like Promise.all, which Promise.all accepts an array of promises. And what it will do is it returns, well, I should say the promise itself fulfills once the promises themselves complete. And it usually gives you essentially an array of the values that come back from those promises. Now, I am curious, Wes, because I know you know more about this than I do. Promise.all.settled. What is the difference between Promise.all and Promise.all.settled?
So all was initially rolled out when we got promises. And the downside to that is if one of those values rejects, the whole thing is over. So Promise.all takes, like you said, an array of promises. It wraps them up into one mega promise.
Yep.
And it waits for all of the promises to be done. And if one of them takes 1 second and one of them takes 10 seconds, you're going to be waiting the full 10 seconds before you get all of the data, right? But if one of those were to reject, you might have 2 successful promises, but there's no way to get that data anymore because it's rejected, and immediately you go straight to the catch when you're chaining, right? So that's kind of a pain if you do care about the successful ones, but not the one that was failed, right? Like, for example, if you're uploading 7 photos, you might want to do Promise.all and upload all 7 concurrently, all at the same time. However, if one of them doesn't upload because it's too large or it's the wrong file type or something like that, the other 6 that may have been uploaded correctly or are still in process, they're all aborted, right? And you're out of luck. So all settled will return to you an array of the results, regardless of if they were all successful or not. They'll give you an array of 2 types of data. Each item in the array will have a status, which is fulfilled or rejected, which is a little annoyed to me that it's called fulfilled or rejected. Shouldn't that say resolved or rejected? Maybe not. And then on successful ones, you'll get a value property, which has the data that you're looking for. And then the errored out ones, you'll get a reason property, which will have whatever is passed to the rejected method that you have there. So I would say, I don't know, unless you want to abort everything, abandon all ship as soon as one of them breaks, you probably want all settled in most cases.
Yeah.
And then Promise.finally, you mentioned this last show of it being really handy, is if you want to do something after it resolves or rejects, like turn off a loader, then you can use finally, and that will run in either case. Now, there is also, I can confidently say I've never used either of these.
Yes.
I'm curious if you ever have either. There's Promise.any and Promise.race. Do you want to guess what those are for, unless you've used them yourself? And what the difference is?
You know what? Just looking at these, I would say that any resolves once any of the promises have resolved. But Maybe, okay, here's what I'm going to guess. This is just totally off the wall guess for me. I'm going to say they both return once the first promise resolves. I would imagine that maybe any also resolves the other promises where race stops trying to resolve the other promises.
It's close. So they both, you're right in that they both will resolve as soon as the first promise is uploaded. So maybe you have two different APIs and you're sending data to two because you want to have like double backups, right? And you only care that something has been sent to one of them, right? And both of those will resolve as soon as the first one is finished. The difference being that Promise.race will return the first settled value, and a settled is a reject or a resolve, whereas Promise.any will return the first fulfilled value. So any is success only. Race will return the rejected or resolve value. So
the first one,
again,
okay.
I don't know. Like, in what case are you firing off multiple promises? Maybe like if you had a promise that was waiting for a click on multiple buttons.
Mm-hmm.
So you might have like 6 promises that are waiting for clicks on 6 different buttons. You might only care as soon as somebody clicks one of those buttons. And as soon as somebody clicks one of those buttons, then you want to continue on with the rest. So, although like just you could pass in multiple selectors to something like that as well. I don't. That's a contrived example that I'm trying to twist into working here.
Well, if you're out there and you're listening to this and saying, guys, I have the perfect use case for this, hit us up on YouTube, drop a comment in the video below this video. I want to hear what people are using race for specifically, because I have used any, but I've never used race before. And either way, these aren't things I need to reach for very often. Let's talk about error handling within promises. Now, typically, if you're chaining methods on a promise, you can always add a .catch method that takes a callback with the error that gets returned there. So you've seen that where it has a callback with an E or an error. Then you can console log the error, you can throw it to Sentry, you can do all kinds of stuff with it to ensure that your UI is responding accordingly to whatever is happening with that .catch. Now you can also use a try catch statement to wrap your await inside of when you're going to await a promise. However, one thing that I learned from Wes a little while ago is that you can mix these approaches where you can await a variable result, but still chain a .catch onto that bad boy, so that way you don't have to wrap the whole thing inside of a try catch. I don't know why, but try catch feels so obnoxious to me. It indents my code all by one. It feels like it takes up a lot of space. That's one of those ones where it's like, I will use the .catch method and I will use await to get the value out of a promise typically.
One kind of way that I've been writing a lot of my promises lately is this idea of writing a wrapper function around your promises that will internally run a try catch and will return from that function what's called a tuple. And a tuple is like an array that has a known length and a known type. And back in the day in Express.js and Node.js land, the way that it worked is your callbacks would often give you the error and the data. And you would either have the error or the data. And that was really nice because you could first check if there was an error. And if there's not, you can continue on with the actual data. And that's a little bit tricky because you could do try catch and then you got to update variables outside of the scope. That's kind of annoying. You can use the await and .catch. But if you want the actual error on the next line, then again, it's out of scope. You don't have access to it. You got to do some weird variable things. So with this idea of, I call it collect. In my TypeScript course, we create a function called collect and learn how to like use generics to type something that is so abstract. But there's a really popular library out there called await2js. And this will just give you a function that you can wrap your promises in, and then it will return to you an array. First item being the actual error, second item being the actual data. And that's really nice if you need to first deal with an error before you go on with the rest of everything. Most commonly being like you try to save an item to a database, you get the result back. You want to first check, was there any errors saving that item to the database? If so, then render an error page. If not, continue on with the rest of the page, maybe render out the user page. So I've been a big fan of this approach.
I have two statements on this. One,
yes,
we should take your collect and turn it into a library, and we can call it collect call. That's good. That's a good joke.
Oh,
yeah,
that's great.
Thank you.
Yeah.
And second, just even saying this makes me wonder why, dot catch, or even like it feels like the error should be the first in my logical brain when you're doing a promise. Like, oh, if this fails, take care of the failure first. And then if it didn't fail, we know it succeeds. Like logically, the order of that makes way too much sense. I've never used await to JS or any of this stuff before, but I like the way it reads when you look at the code.
Yeah, I always was a big fan of this approach. I think it was, I'm trying to wonder, like, who popularized this in Node.js land? I think some of even the Node APIs that are callback based were like that. It's been so long since I've worked on it, but yeah, it was always give you the error first, then the data, and that forces you to think, okay, handle the bad case first, and then you have your happy path.
Gotta have your happy path.
So yeah, I have a little YouTube video I'll link up here detailing the different async await error handling strategies, because not one is better than the other. I use all of them. Sometimes a try catch, sometimes a catch is good. Often a mix and match is really good. And then if I'm doing it, specifically when I do a lot of like Node.js database work, I'll reach for the collect or await to JS implementation.
Yeah. Yeah. It is interesting because you, like you said, like you do it different ways. To me, it's one of those as a feeling things, because you can typically write most of the stuff you're going to do with any of these approaches. And I think over time, you just kind of get a feeling for which way you like to do what. And that's typically how it feels for me.
I have a really good Promise.race example. So often when I don't know how people use APIs, I'll just go on GitHub search and search for that API and see.
I do that too.
Scroll through 15, 20 different code examples. Like, what are people actually using this for? And you know what? This is such a good example of what it's used for, is that if you want to add a timeout to something that has a promise, but that promise doesn't have the option to pass it in, like you're using somebody else's API, they don't allow you to pass in a timeout, right? Or you have your own promise-based function, but then you have to re-implement the timeout functionality in every function. And you have to add a timer to it, and that's annoying. That's one of the nice things about fetch, where it's built in, but not everything is a fetch. So Promise.race, what you can do is you can say const result equals await Promise.race, pass it your original promise function, and pass it a timeout function that will throw. Yeah. And then that's beautiful, because
that makes sense.
Either or not even throw. You could just resolve after 1 second. And then if the result is empty, then it timed out. And if the result is there, then it worked. Love that.
Hey, love that.
Yeah. Oh, I learned a thing or two. Last thing we have here is the capital P promise in JavaScript has two static methods on it. So .reject and .resolve. And I've always wondered, like, why are those there?
Yeah.
Like, what are those for? And I realized I had used them a couple times, is if you are returning values from a function that may not be a promise, but you want to still maintain the whole promise API because everything else you're working with is a promise. So for example, you might have a cache API that it either fetches some data and returns to you, or it will just pull it out from the cache and return it to you. So by returning promise.resolve with some data, it just turns your static data, like promise.resolve 42, it turns it into a promise that immediately resolves to 42. And that's great if you're trying to like keep the chaining, or you're passing something to a function that expects a promise and not just a straight up value. So I think async await kind of did away with the need for most of this stuff, because if you have an async function that returns 42, that's the same thing. But if you need to turn a function that returns a value into a function that returns a promise of a value, that's where you use reject and resolve methods, the static ones on capital P promise. That's, what are we at here? 23 minutes. Yeah, that's enough for a part 2. Hopefully you learned a thing or two. On next Monday, we have the 3rd installment of the series coming out, where we're going to talk a little bit more about queuing and concurrency and running promises in series, and a whole bunch of libraries that are helpful for working with this type of stuff.
Sick.
All right. Talk to you later.
Peace.